Hello, my little mathematicians. Today, I'm going to help you with your warm-ups reviewing expressions and algebraic representations. As always, this is review, so please try it yourself first, pause the video, try it, and then unpause it and come back and join us to see if you got it right. Okay, for the very first one, to simplify that expression, we're going to do Pemdas or GEMDAS. So go ahead and write that little reminder to yourself. Grouping symbols first, then exponents, multiplication or division, and then addition or subtraction. Okay, I do see parentheses, so let's simplify that first. 2 plus 4 is 6. Bring everything else down. Parentheses are down to a single number. There are no exponents, multiplication or division. When you have a number touching a parentheses with no signs between it, that means that those are being multiplied. So 3 times 6 is 18, divided by 9, minus 28. Okay, I still see some multiplication or division. So 18 divided by 9 is 2. Now bring this down. Again, multiplication or division before addition or subtraction. Now I'm on to my last step, 28 minus 2. You should have gotten 26 for your final answer. Okay, for this one, write an equivalent expression to each of the following below. Let's say they actually gave you more descriptions here and they wanted you to use the associative property and write an equivalent expression for this one. They wanted you to use the distributive property to write an equivalent expression there. And they wanted you to use the commutative property, that one. Okay, so for the associative property, that means who's hanging out with who changes. So let's, instead of having 6 hang out with 5, we still want the same order, 14, 6, and 5. That doesn't change. But now 14 is hanging out with 6 instead of hanging out with the 5. So who's associating with who changes. Think of the grouping symbols as who's associating with who. Distributive means I distribute the number out in front to each number inside. So 6 times 5 plus 6 times x. Well, 6 times 5 is 30, and 6 times x is 6x. Okay, and then finally, for the commutative property, these ones can move. So you can change the order up. So 7 times 3 times 5 is still the same thing as that. Or you could have moved the 3 from the back to the front. Okay, as long as you still have a 3, a 5, and a 7, they can move order. Okay, that's what the commutative property means. All right, we're going to identify the independent versus dependent variable from this word problem. Okay, the cost of 2 pounds of broccoli is $4.59. What are the independent and dependent variables? So we're talking about the pounds of broccoli and how much it costs. So I like to say it both ways, and then one way will make more sense than the other. How much money I spend depends on how many pounds of broccoli I bought. Or how many pounds of broccoli I bought depends upon how much money I spent. Which way makes more sense? Obviously, it's the money you spent. The cost depends upon the pounds of broccoli that you bought. Okay, next one, write an equation to best represent the relationship in the table. So they want y equals something x, and we need to determine what that constant is. Okay, I know that sometimes we use a, but sometimes you'll also see them use an m, basically any variable, but the most common one they use to represent the number that's going to go in front of your x is a or m. Okay, so the a or m, the constant, is usually the change in y over the change in x. So from right here to here, what was the change? This changed by 7, right? And then the x changed by 2. Well, 7 over 2 is 3.5, which means the rate of change should be 3.5. In order for that to hold up true, each time you have your x, you should multiply it by 3.5 and get your y. So go 3 times 3.5 in your calculator. Did you get 10.5? Good. Okay, then do that again. 5 times 3.5. Do you get 17.5? Perfect. Okay, it has to hold up for the whole table to be true, though. So 7 times 3.5. Do you get 24.5? Awesome. Okay, 9 times 3.5. Do you get 31.5? Okay, it's almost totally 100% true. Let's see. 11 times 3.5 is 38.5. Is that true? Perfect. Okay, 13 times 3.5 is 45.5. Is it? Perfect. All right. So since you took your x and multiplied it by the constant of 3.5, and every time it gave you this y, you know that that is your equation that's going to work. And how you found that constant is you find the change in y's. So how much did the y's change? It went up by 7. For how much did it change in the x? So the change in y over the change in x. Once you simplify that, that should give you your constant or slope. Beautiful, my little mathematicians. You are just mastering so many concepts.